List all possible rational zeros for each of the following polynomials. So here we have f of x equals 6x cubed plus 17x squared minus 31x minus 12. Now, this is sort of the groundwork for when you are using guess and check for factoring quadratics, but it's a process that works for cubics and beyond. So effectively, what you're going to do is you're going to focus on two numbers, the leading term coefficient and the constant. So the first thing you do is list out all the factors of the leading term coefficient. So since you have the value 6, that could be 1 and 6 could be factors. So I'll list 1, and then I'm going to put 6 a bit later. I'm going to get these in order. 2 is a factor, because 2 times 3 would give you 6. And then, of course, 6 itself. So 1 and 6 are factors of 6, and then 2 and 3. Now, I've included positive or negative cases because either one could be possible as well, because it could be -1 times -6 to give us +6 and so forth. And now we also list out factors of the constant. So factors of the constant 12, we could have 1, 2, 3, because 3 and 4 would give me 12, 2 and 6 would give me 12, and then 1 and 12. So those are all the factors of the constant. Now, what we do is anytime we have a potential rational zero, so I'm going to make a list of all possible rational zeros. These are always going to be of the form some factor of the constant divided by a factor of the leading term coefficient. Okay, so if I take each of these values in the constant list and divide them by each of the values in the leading term coefficient list, that gives me all the possible rational zeros. So first off, all these values divided by 1, so just themselves. So plus or minus 1, plus or minus 2, 3, 4, 6, and 12. Now I take 1 over 2, so that would be plus or minus a half. All right, and then 1 over 3 is plus or minus a third. And 1 over 6, so plus or minus 1/6. All right, now I go on to using 3 as the denominator. So it would be 1 over 3, which I've already included, so I don't need to write again. Then 2 over 3, so 2/3, that's another one. Then 3 over 3, which is 1, so we've already got that. 4 over 3. 6 over 3 is 2, and 12 over 3 is 4. We've got each of those. All right, now we go with 6 as the denominator. So 1 over 6, we've got it. 2 over 6 is a third, we've got that. 3 over 6 is a half, that's in there. 4 over 6 is 2/3, that's already in there. 6 over 6 is 1, and 12 over 6 is 2. So it looks like these would be all the potential rational zeros. And just double checking myself, it looks like I might have missed a combination. You probably noticed it in the video, but 3 over 2 would have given me 3 halves as another potential location. All right, the next one here. So again, I'll just list factors of the leading term coefficient. So for 15, 1 is always a possibility. In this case, 3 then, 5, and 15. So there's not very many there. And factors of the constant could be 1, 2, 4, and 8. All right, so my possible rational zeros here. Let's see. I'll start with 1 and divide, put that constant value in the numerator with um, all the leading term values in the denominator. So 1 over 1 is 1, 2 over 1, 4 over 1, 8 over 1. All right, now I'll move to the 3. So this would be 1 over 3, so 1/3. 2 over 3, so 2/3. 4/3. And 8/3. Okay, now we go on to the denominator of 5. So 1/5. 2/5. 4/5. And 8/5. And the denominator of 15 could be 1/15, 2/15, 4/15, and 8/15. And that would be the entire list of possible values.